As we wrap up Chapter 2, I want to talk about a couple of points dealing with atoms, compounds and how we write the formulas for compounds, and a review of the main topics of Chapter 2. When we're looking at atoms are found as individual pieces of an element. The smallest individual component of an element can't be broken down any further and still have all of its properties. The symbols that we use are always going to be abbreviations for the elements. These are the abbreviations we're used to seeing on the periodic table. What you're going to see is these abbreviations always follow a basic pattern. They're always going to be 1 or 2 letters long. There are occasional cases where you see 3 letters, but those are placeholder names that will eventually be replaced by a final name that will be only 2 letters. The symbols in chemistry are the main letters that we use when we write things. So if you think of letters when you're writing a word, we use symbols when writing words in chemistry. The first letter is always capitalized. The second letter is always lowercase. It allows us to distinguish between when we have 2 different elements or one element that has 2 letters in it. Compare CO and C capital O here at the bottom. C lowercase o, that is the element cobalt. We know it's a single element because we see 2 letters, one of which is capital, one is lowercase, so it's all the same element. In the second case, where we see CO, we know that that is carbon monoxide, carbon and oxygen. 2 different elements because we see 2 different capital letters. So each time we see a capital letter, we know we have a different element. Compounds, if you remember, always consist of 2 or more elements. The way that we write compounds is to use subscripts to identify the number of each type of atom that's in the compound. Subscript 1 is always understood, so if you only have 1 of a single element, you just generally do not write the 1. Here's an example of the compound sulfur trioxide. Sulfur, S, capital, O, capital for oxygen. There's 1 sulfur, we don't write the subscript 1. 3 oxygens, we do write the subscript 3. So we see SO3, meaning 1 sulfur, 3 oxygens in this compound. Here's 2 examples. Take a second to try these on your own, and then we'll go over the answer. So if we want to write the formula for the compound with 2 atoms of nitrogen and 5 atoms of oxygen, we would write the symbol for nitrogen, a 2 to tell us there's 2 nitrogens, the symbol for oxygen, and a 5 to tell us there's 5 oxygens. Glucose, and we're going to write these in the order they're listed. C6, H, the symbol for hydrogen, 12, O6. So it's pretty straightforward how we write the names for compounds, the symbols and formulas for compounds. We'll get into a lot of the names and how we actually go about putting these formulas together when we get to Chapter 4. Just to review Chapter 2, Chapter 2 is all about matter and what the types of matter are and how we go about changing that matter. Remember, matter can be one of 3 things. It can be a mixture, either heterogeneous or homogeneous. Homogeneous being the same all the way through, commonly called a solution. Heterogeneous being pockets of different materials, can be called suspension, colloid, or a pure substance. You can make a physical change to turn any heterogeneous or homogeneous mixture into a pure substance by separating that mixture. Pure substances come in one of 2 forms, either compounds or elements. Compounds have 2 or more elements bonded together. Elements is a single element by itself. You can do a chemical change to go from a compound to an element. Simplest piece of a compound is known as a molecule. The simplest piece of an element is an atom, except for those cases where we have the 7 diatomics, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, that Hofbrinkel, where they would exist as molecules. So that wraps up Chapter 2. The next thing we'll get into is Chapter 3, looking at atomic theory and the periodic table.